Well, I think we're down to the last segment of this Frugal Repairman, at least with this RCA radio. I'd like to accomplish two things today. One is to talk about what you do if when you replace the capacitors and replace the resistors that are out of tolerance and all of that. What if the radio doesn't work? Where do you go from there? In our case, it worked, and I will tell you that I can't remember a time when the radio didn't work if I hadn't made a mistake myself. In other words, if you replace a capacitor and get it in the wrong place, or you replace a resistor and you thought it was a 10K but it really was a 100K or whatever, those mistakes can still happen and cause the radio not to work. But generally, if you're careful, if you put everything back right, if you test your capacitors before you install them, the new ones that is, almost always the radio works. But let's suppose it doesn't. The second, and also as I go through a little of that, I'm going to talk about a few little things to kind of clean up a few areas that I was going to mention at one point and never did, and so on. Then what we're going to do is finish cleaning the case, because the glass, I think in a previous episode you saw that my wife has done a wonderful job of getting those paint spots off, but I had asked her to leave the glass alone, and I would clean that, partly because you do need to be careful when you're cleaning the glass that you don't use solvents unless you know it's safe. So we'll talk about that in a little bit. And then finally put this into that cabinet and take a look at it and kind of wrap this whole series up. So the first thing that I want to talk about is what you do when the radio doesn't work. And it's you really need to have some service data if you want to make it easy on yourself. Now, fortunately, there's a lot of service data available online for most of the radios from the 30s, 40s, and 50s. But there are differences in the service data, and so I thought I might talk about just a few things and show you what is going on here. Notice that this is a schematic. This is the schematic I've been using. It is from the Rider manual. That is Rider's technical manual. And you notice over here where I've shown some of the changes that we've made and so on. Down here, notice power supply polarity. Notice this 3-volt fixed bias. You don't need to pay attention to the details. I'm just pointing out some things on this one that are different on the RCA data. Now here is the same schematic from the RCA manual of the time. Notice that down here there's no power supply data. There are cathode currents that were not shown on the other one. Notice over here the 3-volt fixed bias, instead of being down here, is up there, and there are a number of little differences like that on this schematic. Basically it's the same thing, same voltages, same basic schematic, but you will find differences between one set of data and another, and sometimes you'll find that there were changes made. And so one set of data might show a particular resistor. For example, just as an example, R4 is a 3.3 meg. Well, it may be that they decided to change that to a 4.7 meg in a subsequent run of this chassis. So some schematics may show 3.3, some may show 4.7, or this capacitor may have been changed to a 0.022 or a 0.033 or something. So don't take the schematics as necessarily the only representation of the radio. Your radio may vary a little from the schematics, even if you have a period correct radio diagram. Okay, now suppose that you get to the point where you've fired up the radio, you've replaced the capacitors, you're pretty sure you did everything right, and it doesn't work. The first question you have to ask yourself is it producing B+? In other words, does the radio turn on, do the tubes light up, the pilot light comes on, and does it draw about the right amount of current? Because if it doesn't, then you need to start looking at things that are tied just to the AC line. Maybe you have a bad on-off switch. Maybe when you rewired something, you rewired the rectifier wrong or something of that sort. But assuming that it does power up and you do get B+, the next thing you should do, and by the way, I'm assuming that you already have checked resistances, is check the voltages, especially the plate, grid, and cathode voltages. And in the case of a tube which has more than one grid, check the screen grid. Plate, screen grid, control grid, cathode voltages. From that, you should be able to deduce what's wrong with that stage. But there is a trick that a lot of repairmen of the day used to kind of isolate what is going on in the radio. And I'm going to illustrate it here, and then I'm going to show you some videos that I did some time ago that talk about this in more depth. What they would do is they would insert a capacitor, just touch a capacitor to the arm of the volume control. I'll show you where that is here in a second on this radio. And they would use a capacitor like this. At least this is the safer way. Now, I'll be honest, a lot of us used to use just our finger, but the safer way is to hold a capacitor with one end and use the other end to touch the arm of the volume control. You turn the volume control up a little ways and you touch this. You should hear a fairly loud 60 cycle hum in the loudspeaker if the audio amplifier and the output audio output tube and the audio output transformer and the speaker are all working. In other words, what you're doing is you are splitting the receiver into all of the audio, including the power supply. And if you've got audio, then you know that your problem is either in the detector or in the IF or converter stages. Because if audio gets through here, then if the detector is working and getting an RF signal, an IF signal, you will hear a radio station. So let me show you a set of videos that I did some time ago in which I talk more about isolating to a given spot in the circuit. Here is my number 41, and this is the first part of a three-part series about an AM/FM radio. This particular one is made by Westinghouse. And if you're interested in more of this idea of how to isolate stages, I suggest you might go back and watch 41, 42, and 43. It also talks about a number of other issues, for example, replacing selenium rectifiers and other things that we didn't talk about with this radio because they didn't have them. So that's a suggestion. Another suggestion is that you read the sections in a couple of books. One is Chapter 27 of Elements of Radio Servicing. I'll show you this book in a minute, the front cover. This is available on the internet in PDF form. So you shouldn't have to go out and pay the outrageous prices that these vintage books command these days. But notice that under servicing procedure, it begins with servicing procedure for no reception and continues on for another page or two, and then talks about a 2-point check of a superheterodyne receiver. By the way, he talks about a procedure similar to the one I just talked about with isolating the servicing procedure for weak signals, servicing procedure for hum, and so on. So here is the book. It's called Elements of Radio Servicing by Levy. Let me show you the title page. By William Marcus and Alex Levy. Like I say, you can download that on the internet. Another book that has a very nice set of directions on how to troubleshoot is Rapid Radio Repair. It's a Gernsback publication from 1959. The author's name is Heath, and this is available on the American Radio History website. Notice AC power supply checklist, AC-DC power supply checklist. And by the way, the receiver we were working on was an AC-DC. And because when these first began to come out, some parts of the country, particularly in the Northeast, still had DC current supplied to the homes. So this is a nice set of charts in the back of that book that talk about how you can troubleshoot. It talks about things like the AVC checklist. Let me zoom in a little bit so it's easier to read that. The automatic volume control checklist. The audio frequency stage checklist. Once again, for vacuum tube receivers and so on. So if you want some extra support and help on this, I suggest those two resources. There are others. One other thing that I wanted to mention before we leave this receiver and start putting it in the case is I recommend that you test your new capacitors before you put them in. However, what I recommend is that you test them for three things. One is the value of the capacitor, and you can do that using our Frugal multimeter or any multimeter that has a capacitance scale on it to check them for value. Second thing I recommend is you check them for leakage, but you don't have to do that. It's just a good idea. So if you don't want to go to the bother and expense of building or buying a leakage tester, you don't really need one. But occasionally you will find a bad capacitor even though it's a new unit. And finally, I talked about the outside foil. The fact that on a capacitor like this one, you want the outside foil connected to the plate side. But once again, that is a nicety. You can get away with just sticking the capacitors in either way. Remember, all the outside foil is talking about is the low noise position of this capacitor. In other words, in one position, this capacitor will put less noise into the stage than in the other. But if you get it in reversed, stage will still work. It'll just have a little more noise. So those are a few of the things that I wanted to talk about to kind of clean up before we move on to getting this this unit in the case. So now let's take this radio and finish cleaning up the case, put it in, and turn it on and make sure it works, and declare this series done. Well, here is the case, and notice, as I said before, I owe a debt of gratitude to my wife who cleaned all of that paint off of here. That was quite a job, and left a very nice looking Bakelite case and still in good condition. What I'm going to do now is I'm going to clean the front panel here, the glass. And this one I'm lucky because the lettering is on the reverse side of the glass. The side that's facing us is relatively, we can pretty much work on it without a lot of concern for wiping the numbers off. Nonetheless, I'm still going to be very careful. I'll use a damp cloth in a few places, like this little paint spot right up here. I may use a little bit of vinegar. It helps to, well, that one just scratched off. So maybe that's all I need to do is just clean this a little with a little bit of window cleaner. Anyway, let me do that, and then we will put the radio in the case and make sure it still works and move on. Okay, well, it's back in the case. There is a bit of a spot there that, let me turn the volume down. There is a bit of a spot there, and I have left a couple of the paint spots. I felt like it added a little bit of character. They come off pretty easily with just a little bit of vinegar and water, but it is part of the history of the radio, so I thought I'd leave a couple of them on there. Let me now turn off the lights and let you take a look at this without any external light, or very little external light. And there you have it. Okay. Well, I apologize for the the nature of AM radio these days. It's not really my cup of tea, but this nice little radio is. So I hope you've enjoyed this series, and I hope you'll look forward to some things in the future. I will point out that it's now gotten into fall, and that is a busy time for me, and so I'm probably not going to have a lot of time to be doing videos, at least not for a while. But I hope that you have enjoyed this one, and find a radio, fix it up. I think you'll find that it's a very enjoyable hobby. So in the meantime, until I see you again, have a nice day.